Hi, and welcome back to the second part of the refactoring section of this kata. So we are treating with the refactoring kata called lift price pricing, which you can see here. One of the ideas with this kata is to experiment the workflow of legacy code. So when we have legacy code, we cover it with high-level tests. We refactor so that we can reuse the code and work with unit tests. Then we can pull down some of the tests to a unit level because it makes sense. And then we're in a very good position to implement new features using TDD, fast, quick, great, maintainable tests. If you watched before, you will remember that we have extracted this function. This code was all in the controller. It even had the SQL queries inside. Now it's separated out to a DAO or a repository. So in order to test this piece of business logic, we don't need the database anymore. We can just mock the priceDao. We also we're not annoyed by the adherence to the HTTP framework because we have only domain code here. Now we have achieved the reusability of this code. We wanted to create a new feature where we can buy several lift passes at the same time. Oh, that's great. Now that we have this unit function, then we can call that several times and we can easily implement new feature. However, while that's sufficient for the next feature, I think we should go a little bit further. One of the things that I'm not happy with here is that we are repeating this kind of thing here. It hints at a business logic or a business rule, which is that we don't use fractional costs. We only charge like 21 euros or 22 euros, not 21.3. And we always run it up. We don't run it down. That's the kind of thing I want to capture somewhere. Also, testing that this kind of calculations here are correct is not so easy, because in order to test this piece of code, we have to use mocks and stubs for the DAO, and that's not really what this piece of code is about. And it's actually a clear-cut case of primitive obsession. We have this DAO which returns a structure which has a property which is cost, whereas good programming would either have an object that has that method, has some methods on it, or have some functions related to a specific type in functional programming. And that will be very easy to test and very safe from bugs. Well, let's go refactoring. What I'm going to do is I'm going to wrap this bare structure in a class, and I'm going to move all this logic onto that object. So let's create the new cost here. No, let's not do like this. Let's extract this as a raw price first, and then do new cost from raw price cost. Now that has property cost. It is of type number, and we can see that the tests fail now because we're not returning the good thing. But I'm going to make them passed. If I put this property public, then all tests pass because it looks like just like the bare structure I had before. But now I'm in a very good position to make this piece of code move logic onto that class. So let's start with, say, this piece of code. What I want to do in this, want to replace this with the response equals base price, apply percentage of reduction, and then I want to do round up. So I wish this code existed, and I'm gonna make that happen. Now I'm here. I need to return a new cost or mutate the existing one. I'm gonna prefer to create a new one, and I'm gonna use the same logic as before. So this is this cost times 1 minus reduction divided by 100 percentage. It almost works, but I don't have this roundout function yet. Return new cost math seal this. Okay, good. We're green again. And now I can remove this old logic here. And I really think this is more expressive. Now let's replace the other parts here with the same kind of logic. Let's look at this one, which is quite simple. This is basically another way of applying like a 30% reduction, I'd say. Let's try that. Tests are failing, tests are passing. And what's this piece of code? That's a bit more intricate. It's like applying a 25% reduction and then a reduction, right? So that would be apply percentage 25. Oh yeah, that works. So what do we have left? We have this one left, right? So that's like applying a 60% reduction. I don't know. Does that work? Yes, it works. Okay, we're almost done with these raw structures here. We still have this one, and that we can just do like say that this is cost free for free, create the method free, and free is 0, right? I think the tests that are using the MySQL database are not running very well anymore. Let's rerun the tests. Oh, good. No failing tests. So we had this piece of code to replace. Okay. So now we don't have that raw structure anymore. We have moved all the logic to its own object. There are two more details we need to address here. First of all, the DAO should not return a bare structure. It should return a cost object directly. And I do not like this repetition of round up here. So we're going to address that too. First, let's address find base price here. So I am going to, before that, I actually need to extract this class to its own object. So I'm going to move the move refactoring and move that to its own file. Good. And now, instead of doing this, I'm just going to do that. So the tests are failing for now. But as soon as we do return new cost, they pass again. Awesome. Something is a bit strange here. Let's relaunch the tests. Oh. Very well. So we've done that. We've extracted the cost. And let's look at this piece of code. Now we don't have that primitive structure anymore, and let's get rid of the roundup. To get rid of the roundup, we probably want to do is see where this is. Where's this called? So find those usages, and it's used here, of course, in the controller. What we can do is we can just do round up here, and then it works. This, of course, works because it doesn't do anything as it's done twice. But we can allow ourselves to remove this now. Now we don't have that repetition anymore. I like this a lot better. I think it's quite explicit to have these kind of percentages here, and there's not much repetition, and there is little chance that we will miss the fact that we round up. And this cost clause has become very, very easy to unit test, and it makes sense to unit test these kinds of methods. Very well. That's all for this time, and see you again soon. Bye. Thank you for watching.